This is a continuation of section 11.4, Properties of Logarithms. On the last video, we talked about expanding logarithms. We talked about using those properties to take a bunch of things that were inside a logarithm and breaking it up into several logarithms connected with plus, minus, putting the exponents in the front. Everything that we do in math, there's a way to undo it. So today we are going to undo the process of expanding, and we call that condensing. So basically we're undoing what we did. So the last thing that we did, and if I kind of go back up to our notes, the last thing that we did was move exponents into the front of the term. So exponents inside the log become coefficients in front. So if we're undoing that work, the first thing that I would want to do is take any numbers that are in front of a log and put those back as exponents. So we've got log base 4 of y, and this is going to be log base 4 of x to the 1/2. Then I would condense this down to just one logarithm. And I see minus, so I know that there's going to be division because subtraction between the logs is the same as division in between. So the y needs to be on top, and that x to the 1/2, that's the negative log, so that is the one that's going to be on the bottom. Now, I would count this as a correct answer. The book would want you to rewrite this as the square root of x, because x to the 1/2 is the same as the square root of x. Either of these would be fine in my book because I'm really focusing on can you use the properties of logarithms. I don't care so much about the properties of exponents, like x to the 1/2 is the same as the square root of x. In this next example, again, we are going to start by looking at the coefficients in front. So there's a 7 in front, there's a 6 in front. And as you get better at this, like you can even just kind of write that 7 in there and cross it off there, write the 6 there, cross it off there. The key thing here is this x plus 1 is going to stay inside that logarithm, and it's that whole thing raised to the 6th. Then condense this down to one log. Notice no base was shown here. That means it was probably base 10. Well, that means it was base 10 because no base means it's base 10. It's a common log. There's two things. There's x to the 7th and x plus 1 to the 6th. So we've got x to the 7th, x plus 1 to the 6th. Moving on to example 4, use the properties of logarithms to condense the expressions. Actually, I want to see if you can maybe try this next one on your own. Yeah, try this one on your own. Pause it and try it on your own. Okay, I'll be honest, this one is a little bit weird, but I'm going to start with my coefficients, moving those back into the position of exponents. So that's really a to the 3rd, and b plus 1 to the 4th, and c squared. All right, so I've got ln, and I see that there's subtraction in here, so I know that there's division. The a to the 3rd, that logarithm is positive, so a to the 3rd is going to be on the top. B plus 1 to the 4th, that logarithm is negative, so b plus 1 to the 4th is going to be on the bottom. Now, many of you would assume that this c squared would also be on the bottom because plus comes from multiplication. But if it was going to be on the bottom, there would need to be parentheses around this to say that the minus applied to both of these things. So then these things would be multiplied together on the bottom. But the parentheses did not exist. So that c squared is actually also on the top. And that would be our final answer. Now I want to do another one of these to show you what it would look like when it isn't like that. So let's do log base 2 of x plus 3 times the log base 2 of y minus the log base 2 of 6 minus 2 times the log base 2 of z. Ooh, kind of cutting it close in there. So pause the video, give this one a try on your own. Okay, the first thing I always check is coefficients. So I would know that this is a y squared. Oops. Check that. This is a y to the third. And this is a z squared. Okay. Then I would write log base 2, and I see subtraction, so I know that there's a division symbol in here. Okay, x and y cubed both come from positive logs, so x and y cubed are going to be on the top. 6 and z squared both come from negative logs, so 6 and z squared are going to be on the bottom, and that would be my final answer. Okay, this last one, you all remember the distributive property. Because the 5 is outside of these parentheses, this is 5 times the log base 7 of a plus 5 times the log base 7 of b. They're saying that that coefficient of 5 is going to be multiplied to both of those things. So we can use the distributive property to get that 5 in front of both of the logarithms. Then we know that this coefficient becomes an exponent. So that's really a to the 5th and b to the 5th. And then if we write it as 1, we've got log base 7. I don't see any subtractions, so there's not going to be a division symbol. It's going to be a to the 5th, b to the 5th. Now, this answer I would consider to be correct, but there is another version of this that would also be correct and might actually be considered more correct because it's a little bit more precise. Keep the 5 on the outside and think about condensing this thing. This would be log base 7 of a times b. Then we have 5 times the log base 7 of a times b. We could then put this as an exponent to both of these. And the way to put it as an exponent for both of them is to put the a times b in parentheses and raise it to the 5th. And if you remember properties of exponents, ab to the 5th is the same as a to the 5th, b to the 5th. So both of these are correct. I would accept either of them. I just feel that the green version on the left, that this version makes a little bit more sense for how we expand and condense. It's a little bit easier to get to the correct answer than the pink version is. But again, I would accept either answer as correct. You are now ready for 11.4 Part 2 book assignment.